8th grade. Last time we talked about basic perimeter review, and perimeter is just the distance around an object. Now we need to do a basic area review, making calculations of different areas. So get the name, date, title, and here are the notes. Area is the measure of space taken up in 2 dimensions. So we're measuring 2 dimensions like a flat surface on a given plane. We're trying to see how much space is taken up. So we talk about like an area rug or the area of a room. And that's just a flat space. So I like to imagine you have these little square foot or square meter pieces of paper, and you lay them down and see how many you could lay down on a flat surface. So that's just what area measures. Irregular areas can be broken up into smaller pieces, so that's really helpful if you're looking at a shape and you're like, I don't remember a formula for this weird wonky looking figure. I don't know how to calculate that area. Well, then we just break it up into little sections that we do know, typically rectangles. We'll break them up into different rectangles that we know. Again, I want to give you the area of a circle because we will use some circular figures, and so the area of a circle is equal to pi times the radius squared. Again, the radius is the distance from the center of a circle to the circle, to the outside of the circle. And then the final note is that area is always measured in square units or in units squared. So it wouldn't make sense to try and measure an area of a rug in just feet. Like if you can measure a foot out, but you can't cover up a 2-dimensional space with a foot. What you have to do is you have to make a square that is 1 foot by 1 foot. And then you'll see how many square feet. How many of these 2-dimensional shapes could cover up that entire space, that 2-dimensional space. So that's why we always use units squared, and hopefully that makes sense. A 1 foot by 1 foot space, 2-dimensional space, is a square foot. So we use all different types of square units. Square miles for big spaces, square inches, or centimeters for smaller ones. Let's look at this example. Oh, we're not calculating perimeter anymore. We're just doing area. So the most common area problems, we're just dealing with rectangles, and we're just saying the area of a rectangle is the length times the width, and that should be familiar to you. So if you're calculating area, you just need to multiply length times width. This needs to be especially familiar if we have those irregular shapes. We'll break them up into smaller spaces like this. So the area is going to be equal to 23 feet times 11 feet. There's a trick with 11s. Where you can break it, and I'll show it to you. So we know that when we multiply these, we're going to get 2 in the front, 3 in the back, and then in the middle we have to add the 2. 2 and 3 is 5. So this, and you can check my work, this would be 253 feet squared, or square feet, and hopefully that makes sense. The other idea here is that this area, I use this example because this area makes sense because if you cut this up into 11 1-foot sections and 23 1-foot sections, you'd have 23 groups of 11 or 11 groups of 23 to count these little spaces. And so that's why it's length times width. We're just having multiple rows and multiple columns, and that will break it into one square foot sections. So length times width gives us that first one, easy enough for a rectangle. This problem should look familiar, but we're going to now calculate the area. So hopefully from last time you remember that, well, what do we know? This probably has a length of 4 feet, or does have a length of 4 feet, since we have a rectangle below it and the opposite side is 4 feet. Then the radius would have to be half of that, which is 2 feet. So we have an irregular shape, so what we can do is we can find the area of this bottom rectangle first, and then find and add the area of the top section. So this bottom section, this rectangle is just length times width. 12 times 4 would be 48 square feet. And then that top circle, we need to use the area of a circle formula. Area of a circle is equal to pi times a radius squared. And our radius in this case, we already said, is 2 feet. So this will be pi times 2 squared. 2 squared means 2 times 2 is 4, or 4 pi. And we can estimate that if you guys like, which you do, because I'm asking you to copy down the same work that I include. 16, 4 times 1 is 4, plus 1 is 5, 4 times 3 is 12. 12 and 56 hundredths. Now the important part to realize is that would be the area of an entire circle, but we only have half the circle we want to include. We already have this whole section below the top half, so we need to divide that by 2. So 12 and 56 hundredths would be the area of an entire circle with a radius of 2. We need to divide it by 2 and find that we get 6 and 28 hundredths. So our total our total area for this figure is going to be 48 plus, so the area of the rectangle plus the area of that semicircle, that half circle, and that will be 54 and 28 hundredths feet squared, or square feet. So hopefully that explanation made sense. You understand breaking it into different chunks, different parts. We're going to see one more example of breaking it up into chunks. And again, it's familiar to what we did last time. These examples are too good, I had to leave them the same. So again, we figured out that, all right, the distance from top to bottom is 17 meters as is stated over here. We already have 7 meters below and 5 meters above. That leaves us with 5 more meters for this section right here. This whole distance from left to right of the bigger section has to be 15 meters. We know that to get here, we've already gone 9 and came back 2, so we've already gone a distance of 7. So if this is 7 meters, then the extra section must be 8 meters. Now, this one seems a little difficult. Well, what are we going to do? We can break this one into separate sections as well. Oh, did not mean to do that. We can break this into separate sections so that we can find the specific areas and then add them all together. So let's find this bottom section. The area of this bottom section has a length of 15 and a width of 7 meters. 15 times 7, we can do that mentally. There's a number of ways to do it. 7 times 5 is 35. Carry a 3. 7 times 1 is 7 plus 3 is 10. So that bottom section is 105 meters squared. Let's cut it into another box right here. And we know that this is 7 meters wide and 5 meters long. So length times width, 7 times 5. This is another 35 square meters we need to add. And then finally this top section is 9 meters wide, 5 meters tall. That'd be 45, length times width, 45 meters squared. To find the total area, we just need to add up the individual sections. So 45, 105, and 35. What are we going to get? 5 times 3 will give us 15. 4 and 3 and 1 is 8. So this is 185 meters squared. So that's the total area. Again, it's easier in this case to find the missing lengths and then break it up into sections that you can calculate and add together. So if we add those individual areas, we find the total area. I'm going to leave you with some problems to work on your own. Hopefully you can see this. In this measurement, we have this top little width is 15 inches. It's a section that's 15 inches tall here. The whole shape is 30 inches tall, and the whole width of the shape is 35 inches. Also, I'm going to ask you to find the area of this circle if the radius is 7 meters. So fill in those missing measurements, break it up into smaller pieces if you like, and make those calculations.